Greetings to all. This is Dr. R.R.RAVIKUMAR. In this session, I would like to discuss about the storage class in C language. So, what is a storage class? Generally, when we declare a variable, it has to be allocated some amount of memory and where it has to be allocated. So, that is what till now we have not specified any storage classes, whatever the program so far you have written. But we need to specify where the memory for this variable should be allocated. For that we are going to be use storage class. It will define the scope of the variable and it will define the scope of the variable, lifetime and visibility of variables. So now if you go with this types of variable storage classes, we are having four types of storage classes: automatic, register, static and external. For all these types of storage classes, the keyword that are existing in the C language are: first one AETO, auto, for automatic storage class, REGISTR, register storage class, and next one is static storage class, and the last one is external storage class. So while declaring the variable, so generally we will follow data type space variable name. This is how we declared. But whereas coming to the storage classes, we have to specify storage class before the data type. That means here we have to specify the storage class. Sir, till now we didn't specify any storage class in the earlier program. Yes, int a. Why we are not specified means there is a among these four, one will be considered as the default. One will be considered as the that is particularly automatic will be considered as the default storage class, and remaining are explicit. We have to specify. If it is a register, here we have to write register. If it is a extern, you have to write here extern. If it is a static, we have to write here static. For auto, no need to specify because the default storage class is auto. Now, automatic storage class, that is auto. As I told you, it is a default storage class for local variables. The scope of this variable will exist within the block. Within the block. Within the block. Suppose I have written simple one program void main. Now, if I declare int n, now what is the storage class of this n means? As I have not specified here means it is a auto. It is a auto, or you may write explicitly auto int n. Now, next within that, if I declare the scope of this particular variable n will exist in the entire block of this main function, as we declared this variable at the beginning of the block of this function. So the scope of this particular variable will exist in this block, entire block. Suppose if at all we are having a sub block here, in the sub block if I declare int n, int m, then the scope of this variable will exist only within this block. Apart from this block, we can't access this m. And what about this? Where the memory is going to be allocated? The memory will be allocated in the main memory. Main memory. Let what is this int n? First one is int n. 4 bytes will be allocated for the n. Let it be. It has been allocated at 1001. And coming to the second variable that we declared int m, let it is also a auto. As we have not specified any storage class here, means what is the storage class? The default storage class is auto. So m is also auto. M is also auto. Where the memory is going to be allocated for the auto storage class? In the RAM, main memory. So in the main memory, let the memory has been allocated for m is 2001. So the scope of this m will exist only within this block, whereas the scope of this set exists within this entire function block. Okay, hope you understood this scope. Okay, lifetime till block execution. So if we execute this particular one, so after coming out from this block, we can't contain this particular memory location. Okay, then next Yeah, I already explained the example. Now next one is register. Next one is register. Yeah, register is the keyword we are going to be used to declare a variable as register. What is register? So we are having CPU. In the CPU there are several registers are there. In the CPU there are CPU central processing unit. We are having ALU and etc. arithmetic logic unit. Apart from that, yeah, control unit. Everything is there in the CPU along with the registers. That is program counter register, general register R1, R2, etc. Now, likewise, several registers are there in this register. Where these registers are existing? In the CPU, not in the main memory. In that register we would like to allocate the memory. What is the use? What is the use means, if at all I am going to be allocated, declare it as a auto, means memory will be allocated at in the main memory. Where the memory will be allocated? Main memory. For which case? For the auto. For the auto case, memory will be allocated in the main memory. Let it be 1001. Let the variable name is some a. Now to access that a from the main function, so the value from this main memory has to be fetched into the CPU for the purpose of arithmetic operation. Suppose I am using for a plus plus, then a value is initially 10, a plus plus it should be become as 11. Who has to do it? That should be done by the CPU. Where in the CPU we are having arithmetic logic unit. There it is going to be increment. But how it is going to be do? This data has to be fetched into this CPU. For this fetching the data from main memory to CPU and storing back from CPU to main memory, it may take much time compared to the remaining case. Now in such case, to reduce this time, suppose I would like to access this variable frequently, then in such case the time taking to transfer the data from main memory to CPU and CPU to main memory will be expensive. Then in such case we are going for the register storage class. Suppose I declared a variable called, I declared a register variable, register int I. For I assign 1, I less than or equal to 10, I plus plus or 100, I plus plus. Now how many times I would like to access I? 100 times. In such case, as I told you right now, so data should be transferred from this location instead of A. Now what is the variable I have taken? I. Now from here the data has become, if it is not registered, then if it is auto, the memory will be allocated in the main memory. Then in such case data is going to be transferred into the CPU and coming back. So it will takes 100 times, means 100 times into, let assume that it will take 3 nanoseconds. Then 3 into 100 times 300 nanoseconds we are going to be consumed for this transfer of data. To reduce that, what we are going to be do, we will declare, we will specify the storage class as register. In such case the memory will be allocated. So instead of allocating in the main memory, one of the register will be assigned to the I. So now this whatever the register, some one of the register will be assigned to our I. Now what is I value? 1. Now this time has been registered because I value is existing only within the register. Now I would like to increment the I. Where is that I? I is already in the CPU. It will save this time. To save that time, we are going to be use register storage class. So where the memory is allocated means in the register. So in the register means the storage placeholder is registered. So we can't access the memory address of that particular register variable. So that's why in this particular register storage class we can't access address of operator. If it is not register, if it is not registered means it might be auto. Then in this case, suppose int n, what is the storage class? As I have not mentioned it, it will be treated as auto. Then we can access address of n. But whereas coming to the register, we can't access address of I. Why? The placeholder, the data placeholder is the register. So that's why you can't access the address of. So what is the purpose? Faster access. This time has been reduced. Faster access than main memory. I think you understood this point. Scope within the block. Within the block means, yeah, the general, that is, if at all I have declared within this block, then we can access only I within this block. We can't access I outside the block. Okay, this is regarding
register. And yeah, example, I think I already explained the example. Static storage class. Suppose, now coming to the static storage class, what is the keyword? Static is a keyword. It retains the value between the function calls. That is, suppose here I am defining a function, okay, void function 1, okay. Now here int x equals to 0, x plus plus printf x equal to percentage d x. This is the code I have written in the function 1, and in the main function, I'm calling this function more than one time. Suppose function 1, and again I call the function 1 likewise. Now, if you observe this, the program execution will start from the main function. What is the first statement? Function 1, the control will comes to here. What is the storage class? As of now, I have not mentioned any storage class. Then it must be the auto. Then auto means memory will be allocated in the main memory. In the main memory. For the x, let the memory has been allocated at 1001. In which case, the first function call, the memory is allocated at 1001. What is the value of x? 0 has been initialized. X plus plus, x plus plus. So what is the value of x? Now it is 1. Printf x equal to x value. In the output, what is the value? Output x equal to 1 we got. And is there any statement to be executed here? No. The control will goes back to the main function, that is calling function. Again we are having the next statement as function 1, which is a function call. The control will jumps back to here, and again what is this? We entered into the function, and what is this? This is the declaration. What is the variable name? X. And what is the data type? Integer, and it has been initialized by 0. Did we mention any storage class here? No. Then in such case it will be treated as auto, means again it is going to be allocated the memory for x. It is not guaranteed that it is going to be allocated 1001. Okay, so then it might be allocated at 2001. Then what is the value of x? It has been initialized by 0, and then next statement is plus plus, that value has been 1, and again what is the output? X equal to 1. So after completion of this function, control will comes to this next statement of this function 1 call. Is there any statement? No. What is the output? We got the output as x equal to 1 and x equal to 1. Why this was happened? It has treated as the auto. Now, as we are discussing static, now if I declare this as, if I declare this as static, then again the scenario of this main function will changes, the main memory will changes. What is that? So main function 1 call, we came here, and the declaration is x is a variable, and what is the data type? Int. Where I would like to, what is the storage class? Static means it's local, it is local to block, and lifetime is entire program execution, and it retains the value between the function call, means the memory will be allocated only once. X value, let the memory location is 1001. What is the value that we are initializing it by? 0. Next statement is x plus plus. So this value has been incremented by 1, and printf x equal to percentage. This is the previous output. Now current output is, this is previous output. Now present output is x equal to 1, and as there is no next statement, the control will come back to here. Again we call the function 1, the control came here, and now second time we entered into the function definition of function 1, but here the first statement is declaration of x variable, and the storage class is x. As this is the second time, it will not allocate the memory for this x. Previously allocated memory, that is 1001, will be utilized from the second time call onwards, that is returns value between the function calls, second function, third function call, fourth call, and so on. It will maintain the same x. Now x value is now right now 1, and now it will not allocate the memory, it will use the previous memory location only. But what is the next statement? X plus plus, Now previous x value is 1, now it has been incremented by 1, that is 2. Printf x equal to, what is the value? 2. We got the x equal to value as 2, and we will come out from this function. And what is the next statement in the main? No for next statement. So we will end up here. What is the x value finally? So 2. Even if I go with the next function call again in the third statement also, then in such case again it will not allocate the memory, again it will use the previous memory location. What is the final value there in that? 2, and it is going to be incremented by 1. X value will becomes 3, and so it is going to be displayed. Is it clear? This is regarding static storage class, means it will maintains the values between the function calls. Okay. Yes, I already explained this. Okay. Now, external storage class. This is nothing but a global scope. The scope is global. Lifetime is entire program execution. Declaration is only no memory location. So, if you observe this particular example, you will understand what is that. Suppose here, see this. Yeah, I declared a variable global declaration into v equal to 10. It is where I declaring global. If you declare a variable above the all the function definition, then it will be treated as global variable declaration. In the function main, so I am displaying the value in main. What is the value? V equal to percentage d and address of v equal to u. What are the values that I would like to display? First one is v and the second one is address of v. So what will happen here? First one is into v in the main memory, v for v in the main memory for v. Let it has been allocated at 1001 memory location. It is v. What is the value which has been initialized? 10. Now it is going to be display the output statement. Output statement is in main v equal to percentage d. What is the value? V. What is the v value? 10. You are going to be get, and there is a tab after that. Address of v equals to, what is the value? Percentage u of address of v. What is the address of v here? 1001. This is what we are going to be get. Now in this main function, here I declared a sub block. In that sub block, I am declaring a variable. What is the name of the variable? V. What is the global variable name? V. What is the local variable name here also? V. But instead of allocating the memory, I don't want to allocate the memory for this V. That's why we are using extern key. So it means here don't allocate the memory for V, which is already allocated in the global declaration phase or some another function, some another function. Then in such case, here we are going to be use that memory location. So it will not separately allocate the memory. Now in that block only, what is the next statement? In sub block, in sub block v equal to same memory location is going to be used. What is the v value? 10. And address of v, address of means here it is not allocated, so it is going to be access the same memory location. What is that? Address of v equal to 1001. I think you understand this. So here this is regarding extend. Simple point is memory is not going to be allocated here. That's it. It is going to be utilize the memory which has been allocated global. Okay. Now what if you don't use this extern keyword in this same program? I'm explaining the same code, that is in the same code, except instead of extern I didn't mention any storage class. Means what is the storage class? I am rewriting here. So int v. Now what is the meaning of this? So here it will be treated as a auto, and again memory is going to be allocated for v. Let it be 2001. Now because it is a auto, so as we have not initialized, so suppose if I okay, have not initialized with any value. In sub block, what is the output? V equal to percentage d, some garbage value. Address of v. What is the address of v? Means this is the, this v is nothing but nearer within this block. What is the block here? Sub block. In the sub block we declared v. Then in such case what is the address? 2001 we are going to be get when if it is specified as auto, other than extern, then it will be treated as like that. So if it is, this is the difference between the auto and the extern. So this will be the output if it is declared as extern. If you declare as, if you don't declare as extern, then we are going to be get here garbage value, and here 2001 we are going to be get as the output. Okay. And comparison simply, auto means local and temporary, register fast access, static persistent value, and extend shared across the files.